So let us now proceed to module number 3, which is the continuation of module number 2. In this lesson, we are going to study how ionic bonding happens. The most essential learning competency is to explain how ions are formed, and the expectations are the following. Number 1, describe ions and how it is formed. Number 2, differentiate cations from anions based on their tendency to lose or gain electron. Number 3, show formation of ions using the Lewis dot symbol. And number 4, write the chemical formula of ionic compounds based on the charges of ions. So this lesson is anchored on the division-made module from SDO Caloocan. As I said in our previous discussion, there are ionic and covalent bond. But as of this moment, let's focus our attention in ionic bonding. What is ionic bond? Ionic bond comprise the complete transfer of electrons which will end up in the formation of ions. There are certain steps to follow in showing the so-called transfer of electrons from one element to another one. So let's study it one by one. So the first step is to select one metal and non-metal and then write the Lewis symbol of the given elements. So for instance, we have Na for the sodium and Cl for the chlorine. So we have now the metal as the sodium and the non-metal as the chlorine. After writing down the symbol of the metal and non-metal, we have to write the Lewis symbol of this element. But what is Lewis symbol? In the 20th century, Gilbert and Lewis devised a system of symbols which is known as the Lewis electron dot symbol or Lewis dot symbol for its short term. Its function is to predict how many bonds will be formed by the elements in a compound. It is composed of the symbol of the element and dots, which represent how many valence electrons are there in the atom of the element. So this diagram presents the Lewis dot symbol of some elements in the periodic table, which will be helpful for you as you answer your exercises later. So take a look at this diagram. What have you observed? Looking at the hydrogen, lithium, sodium, potassium, rubidium, cesium, as you observe, they all have one dot, while the beryllium, magnesium, calcium, strontium, barium all have two dots. The boron group all have three dots. The carbon silicon or the carbon group has four dots. The nitrogen group has five dots. The oxygen group has six dots. The fluorine group has seven dots. And the noble gases, helium, neon, argon, krypton, xenon, and radon has eight dots. So as you notice, the group 1, since they are group 1, they have one dot. The group 2 has two dots. The group 3 has three dots. Group 4, four dots. 5, group 5, five dots. Group 6, six dots, and so on and so forth. So it only says that the group number of the element will explain or will determine how many dots are there in the particular element. Okay? So this diagram will help you to understand or to know how many dots are there in the element given. So if you can remember in our previous discussion, the group number of the element is also the one that will determine how many valence electrons are present in a particular element. And for today, additional information is that the valence electron will give us the hint how many dots are there in each element. Because if the element belong to group 3 like boron and aluminum, they belong to group 3, they have 3 valence and they have 3 dots. If the element belongs to group 2 like beryllium and magnesium, Group 2 meaning they have two valence and they have two dots. The carbon, which belong to group 4, has four valence and four dots, while the oxygen, which belongs to group 6, has six valence and six dots. So they are parallel to one another. So basically, the group number will tell you how many valence electron, and that will also determine how many dots. So this diagram is very important for you to be familiar how many dots are present in each element. And of course, in our lesson for today, which is the ionic bonding, Lewis dot symbol is one of the rules that you have to follow for you to work on ionic bonding. So you can check the Google for the picture of this Lewis dot symbol, or you can have this copy. So going back to our procedure, we all know that we have to write the Lewis symbol. All we have to do is to identify first the group number, because the group number will give you an idea how many valence are there, and the valence electron will also the number of dots present in the element. For example, in lithium, since lithium belongs to group 1, it only has one dot because of the valence electron, which is only one. How about the beryllium? In what group does beryllium belong? Let's check the periodic table. So in the periodic table, you can see that beryllium is in the group number 2. So meaning to say, beryllium has two valence, which means that it only has two dots. Next example is the carbon. So for us to know, let's see the periodic table again. The carbon is positioned in group number 4. So group 4 meaning 4 valence, which means 4 dots. So 1, 2, 3, 4. How about in boron? Boron is in the, let's see the periodic, group number 3. So group 3 meaning 3 valence and 3 dots. 1, 2, 3. The oxygen belongs to group 6. Group 6 meaning 6 valence and 6 dots. So 1, 2, 3, 4, 5, 6. And last example is the neon. Neon is one element which belongs to noble gas. And noble gases elements are the stable elements because they have 8 valence electrons. When an element or compound has 8 valence, they are said to be stable. So group 8 meaning 8 valence and 8 dots. So 1, 2, 3, 4, 5, 6, 7, 8. So neon is a stable element because it has 8 valence electron. How about in sodium? So sodium and chlorine, what group are they? Let's see. Sodium is in the group 1, while chlorine is in the group 7. Okay, so meaning if the sodium is group 1, it only has one dot. Chlorine group 7 meaning 7 dots. 1, 2, 3, 4, 5, 6, 7. So 7 dots for chlorine and 1 dot only for sodium. Second step is to use an arrow to show the complete transfer of electron. So for this, the transfer of electron will be from sodium to chlorine. So why? Why from sodium to chlorine? The arrow is from sodium going to chlorine because sodium is a metal which can readily lose its electron, while chlorine is a non-metal which can easily attract other electrons. So the electron of sodium will be transferred to chlorine. Because the transfer is from metal to non-metal. Okay? If you look at your periodic table, sodium is a metal element, while the chlorine is a non-metal. So the transfer will be from metal to non-metallic element. Okay? So the third step is to indicate the formation of cation and anion. So first of all, what are ions? Ions are charged atom or molecule. So from the word charge, it could be positive ion or negative ion. That is why ions are in two kinds. It can be cation or it can be anion. What is the difference between the two? When we say cation, it is when protons are greater than the electrons. So reminder that protons is a positively charged particle when it is greater than the electrons, which is the negatively, it is said to be positive ions or simply cation. Other kind of ions is the anion. It is when electrons are greater than the protons. Remember that electrons is a negatively charged particle, so if the negative is higher than the positive, it is a negative ion or an ion. So how does cation and anion form? Let us see. There are two terms that affect or that could affect how electron or how element lose or gain electrons. There are two terms that could affect how cation or anion will be formed. And one of this is what we call the electronegativity. What is that? It is the measure of the tendency of an atom to attract electrons. How do we know that? The higher the electronegativity, the higher the tendency to attract electrons. So metals tend to lose electrons because of its low electronegativity, while nonmetals tend to gain electrons due to its high electronegativity. So electronegativity explains why chlorine will gain electron and why sodium will lose electron. Because sodium has a low electronegativity because it is metal, and chlorine has a high electronegativity because it is non-metal. So, how do we confirm that that sodium has a low and chlorine has a high electronegativity? I have here a table for that. So this diagram will present to you the electronegativities of the following elements like hydrogen, lithium, beryllium, and so on and so forth. As you can see, the trend is from low to high. From left to right, the electronegativity increases. So meaning to say, the elements which belong on the left side of the periodic table has a low electronegativity, while the elements belong in the right side of the periodic table has a high electronegativity. At the middle, it has a medium amount of electronegativity. So in our previous module, I have taught you that metals are positioned on the left side, while the nonmetals are located on the right side of the periodic table, which explains that which explains why metals has a low because it is on the left, and nonmetals has a high or great amount of electronegativity. So sodium here has 0.9 while chlorine has 3.0. So it is obvious that chlorine has a high electronegativity compared to sodium. So reminder that the higher the electronegativity, the higher the tendency of the element to attract or to get or to gain electron from other element. And if the element has a low electronegativity like metal, they tend to lose electron or give up electron in what we call ionic bonding. That explains why sodium as a metal will lose its electron and chlorine as a nonmetal will gain the electron in this ionic bonding. Okay? Another Another one that will explain how transfer of electrons happens between sodium and chlorine is what we call the ionization energy, or the energy needed to pull or remove one or more electrons from a neutral atom. Okay, so the energy or the ionization energy of a nonmetal is greater than the ionization of sodium. That's why it has a lot of energy to pull or remove the electron of sodium. While the sodium as a metal has a low energy rather. That's why it can easily give up or lose some electrons during the chemical bonding. Take a look at this table. I have here some examples of metals which are lithium and beryllium. The ionization energy are 520 and 1312, while the carbon energy, fluorine, 1085 and 1681. So, obviously, the nonmetals here are the carbon and fluorine has a great amount of ionization energy compared to the metallic elements which are the lithium and beryllium. And so with their electronegativities, the electronegativities of nonmetals here are greater than the electronegativities of metal. So the electronegativity and ionization energy is the explanation why the metal will lose some electrons and why non-metal like chlorine will gain electron from in ionic bonding. And electronegativity and ionization energy will also determine how the transfer of electrons will happen. And from this, it is obvious that it is from sodium to chlorine. So the transfer will be from sodium to chlorine. And by that, the sodium will lose its one electron and the chlorine will gain the electron of sodium. So what will happen now to the proton and electron number of the sodium and chlorine? Reminder, metal, the metal here is the sodium, but the non-metal here is the chlorine, and their electronegativities are now flashed on the screen. So before the bonding happens, the sodium protons and electrons are 11. So this is what we call neutral atom. When the protons and electrons are equal or balanced, it is said to be neutral element. But after the bonding, the sodium loses its one electron because of its low electronegativity. So the electron of sodium will be transferred now to chlorine. So after the bonding, the electrons now of sodium will become 10 only, while the protons still the same. Protons will not move because it is located inside the nucleus, while the electrons, in our previous discussion, it is the one that is orbiting around the nucleus. That's why it can move around. It can be transferred, it can jump from one energy level to another energy level. Okay? So here in our example, the sodium electron number before and after the bonding will change. From 11, it will become 10. So there is a deduction of one electron simply because this one electron is being transferred to chlorine. How about in chlorine? Before the bonding, the chlorine is a neutral atom, meaning the protons and electrons of chlorine is equal. Protons are 17, electrons are 17. But after the bonding, it gains some electron from the sodium. That's why the electrons now of chlorine become 18 from 17. So additional 1 electron. But the protons stay the same. Only the electrons will gain or lose. Okay? So there is what we call lose and gain of electrons. And with that, we can now determine which of the following or between sodium and chlorine, which of these two become the cation and which of these two become the anion. Do you have an idea? Based on this table, which do you think will be the cation? Based on the protons and electron number of the sodium and chlorine after the bonding, which do you think is the anion now? So sodium is the cation and the chlorine is the anion. Why? Because sodium after the bonding has 11 protons and 10 electrons. Obviously, protons is greater than the electrons number of sodium after the bonding. And the chlorine has 17 protons only while the electrons has 18 now. So it increases to 1. That's why the electrons number of chlorine after the bonding is greater than the number of protons after the bonding. So cation, meaning sodium will become the positively charged, that's why it looks like this, and the chlorine is the negatively charged element here, that's why the symbol look like this. Okay, reminder, when valence is less than 4, that is cation, and if the valence is more than 4, that is an ion. Okay, I hope this step is clear to you, because we are now going to proceed to the last step of the ionic bonding, and that is to name and write the chemical formula for the compound form. So as the sodium and chlorine bonded to one another, they are no longer called element because they are two elements combined with each other, so they are now called compound. But the question is, what is the name of the compound? Do we have to call them sodium chlorine? So let us see, because there are certain rules to follow in naming and writing the chemical formula of the compound formed in the chemical bonding. So the first step is to identify the charges of the elements involved. We have the sodium as a positive one and the chlorine having negative one charge. So how do I know that sodium has a positive one and chlorine has negative one? Of course, I have prepared a table for that, charges of the elements. So we'll take a look in this diagram. In the group 1, they all have positive 1. In group 2, they all have positive 2. Group 3, positive 3. Group 4 can either have positive 4 or negative 4. Group 5 has negative 3. Group 6 has negative 2 charge. And group 7 has negative 1. And the last group, or the noble gases, has 0 charge. Okay? So, this diagram is the charges of the elements in the periodic table. You can have this in the Google. You can print one for you, or you can screenshot this slide. Okay, so this will be very helpful in naming the compound and writing the chemical formula. Okay, going back to our steps in naming the chemical formula or naming the compound form in the ionic bonding. So we now have the positive and the negative charge of the sodium and chlorine. The next step is to show the chemical formula. How are we going to do that? If the elements have the same number of charges, like this, they both have one charge, just copy the symbol without writing down the charges of their without writing down the number of their charges. So, Na is sodium and Cl is the chlorine. So, Na is the symbol for sodium and Cl for the chlorine. And we have to follow the number 2 step. Since they have the same charge, which is 1, we don't need to write the charges now. All we have to do is to copy Na and Cl. So there you go. This is the chemical formula of sodium and chlorine because they have the same charge. And how about the name? What is the name of this compound? We have to follow number 4 steps. To name simple ionic compound, copy the name of the metal and change the last syllable of the nonmetal to IDE. So the metal here is the sodium and the nonmetal here is the chlorine. So according to the rule, we have to just copy the name of the metal, which is the sodium, and the chlorine we have to change the last syllable of the chlorine to IDE. So it will become sodium chloride. So it is not called sodium chlorine, but rather it is sodium chloride. We change the last syllable of chlorine to IDE. Okay, let's have another example. Aluminum for Al, it has positive 3, and nitrogen for N, it has negative 3. What have you observed? Yes, they have the same charge, which is 3. So for that, we have to follow number 2 step. Just copy the symbol of aluminum and nitrogen and no need to write the charges. So this is aluminum and this is nitrogen. So since Al is for aluminum, just copy Al and then N for nitrogen. And they have they both have 3, so no need to write the number. So this is the chemical formula for aluminum and nitrogen. How about the name of this compound? Aluminum is the metal here, and nitrogen is the non-metal. So aluminum, we have to copy that because it is the metal, and then we have to change the last syllable of nitrogen and change it to IDE. That's why it becomes aluminum nitride. Gets? But how about if the charges are not the same? How are we going to name the compound and write the chemical formula? The step number 3 is what we are gonna follow. If the elements have different number of charges, apply the crisscross method. What is that? The charge of the first element becomes the subscript of other element and no need to add positive or negative on the subscript. Okay, I will give you an example. Gallium has positive 3 and bromine has negative 1. Obviously, gallium and bromine has different charges, 3 and 1. So for that, we have to follow the so-called crisscross method. So meaning to say, the charge of gallium will become the subscript of bromine and the charge of bromine will become the subscript of the gallium. So take note, the gallium is the metal here and the bromine is the non-metal. So what will be the chemical formula for this? Applying the crisscross method, it will look like this. So the negative 1 will goes to gallium and the positive 3 of gallium will go to bromine like this. And no need to add the positive or negative, just write the number. And since it is 1, I do not write 1 here because it is understood that it is 1. Okay? If there's no number written there, meaning it is 1. Okay? So that is what we call crisscross method. You just have to exchange the number of the charges to the subscript of another element. I hope it is clear to you. So how about its chemical name? Number 4. You have to follow number 4 again. Gallium is the metal, so just copy gallium. And bromine is the non-metal, so just change the last syllable of the bromine into IDE. That's why it become gallium bromide. Okay? So this is how you are going to name the compound formed in the ionic bonding. Take note that chemical bonding happens to attain stability. So how do we know that a compound is stable? A compound should have to gain 8 electrons, should have 8 electrons to gain stability. So that's why in sodium and chlorine, it will go back. Sodium and chlorine, as you notice, when sodium transfer its electron to chlorine, the sodium and chlorine become stable element and it is what we call the sodium chloride. The symbol term for that is the table salt that you have at home. Table salt. The sodium chloride is now a stable compound because they have now 8 electrons. So they are said to be stable. That is the reason why elements bond to each other to attain stability. So stability meaning they have 8 electrons. And that is also why noble gases are stable elements because they already have 8 electrons in their shells. Okay? I hope it is clear to you. So the lesson for module number 3 is done, but I have I want to clarify something on how are you going to answer your activities 1, 2, 3, 4, and the understanding post test. So in activity 1, on pages 3 to 4 of your module, activity 1, locate the metals, non-metals, and noble gases. So just color your module blue if the metal if it if the elements are metals, just color it red if it is non-metal, yellow if it is noble gases, and white if it is metalloid. And then there are guide questions to follow, just answer them. So how are you going to know if it is metal, non-metal, noble gases, and metalloid? So as I mentioned in our previous discussion, the metals are on the left side. The non-metals are on the right side. How about the noble gases? The noble gases are on the last column. Take note of this. Noble gases are the helium, neon, argon, krypton, xenon, radon. So the last column of the periodic table are the noble gases. So no, you don't need to copy this periodic table because it has different color. You have to follow the color coding on activity 1 of your module, which says that noble gases should be yellow. The metal should be blue. The red one belongs to the non-metals. How about the metalloids? The metalloids are this one, these elements which are on the staircase pattern, like a stairs. So the boron, silicon, those are the semi-metals, metalloids. When I say metalloids, they have the property of being a metal, and they have a property of being a non-metal. So they are in the middle. So how about the elements at the center? So just read your periodic table because they are what we call alkaline earth metals, alkaline metal, transition metal. So they are still metal. So what is the color of metal? Blue. So just read your periodic table because there are legend to follow there. Different periodic table of different kind of label. So just take a look at your periodic table. In activity number 2, using the table on your module 5 or module 3 rather, this is 3. Draw a stair step to separate the metals and the non-metals. You know where the metals and non-metals are located. So a stair step meaning just a stairs like this. So you have to divide your periodic table into metals and non-metals. Reminder, metals are on the left, non-metals are on the right. So just divide your periodic table like a stair step for you to separate the metal to non-metals. These are the metalloids, boron, silicon, germanium, and so on and so forth. And then answer the guide question that follow. Correction, this is module number 3. Okay, what is next? And now for you to answer the next activity, it will look like this. So take a look. On your module, you can find a table there. For you to complete the table for element, valence, which element will lose and what is the symbol and charge, and which will be the cation or anion, I will give you some example. Okay, for number 1, we have lithium. So what is the valence selection of lithium? For you to answer that question, you can look at your periodic table, and here you can see that lithium is in the group 1. If the element is in the group 1, meaning it has 1 valence electron, right? So lithium, does it lose or gain electron in chemical bonding? How do we know that an element will lose or gain electron? So if the element is metal, it will lose. If the element is non-metal, it will gain. So that is the rule. As simple as that. So the question is, lithium, is that a metal or non-metal? Since lithium is on the left side, meaning it is a metal element. And since lithium is a metal, naturally, it will lose electron in the chemical bonding. And lithium has a positive 1 charge. And since lithium will lose electron, it will be called now cation. The one who will loses electron will become the cation, and the one or the element which gain electron is the one that will be called anion. Why it become cation? Because the electrons number of lithium is lesser than the protons number of lithium, meaning the protons are greater. Protons are positive and cation is positive. How about the nitrogen? So what is the group number of nitrogen? 1, 2, 3, 4, 5. So nitrogen belongs to group number 5, which means it has 5 valence electron. Okay, nitrogen, is that a metal or non-metal? Since nitrogen is a non-metal, it will gain electron. Okay? And looking at our charges diagram, we can see that nitrogen has a negative 3 charge. So all you have to do is to look at the diagram that I have presented a while ago so that you can answer this. Nitrogen has a negative 3 charge. And since nitrogen will gain electrons, meaning electron number of nitrogen will increase, so it will become an ion because the electrons or the negatively charged particle in nitrogen are now greater than the protons, so meaning electrons are greater and electrons are negative, and an ion is also a negative atom. How about the fluorine? The fluorine is positioned on the group 7, meaning it has 7 valence, and fluorine is a non-metal, that's why it will gain electron. And looking at our charges diagram, we can say that fluorine has a negative 1 charge. Okay? So it is very important that you have that diagram. So fluorine has a negative 1 charge. And since fluorine gains some electron, it will become an ion because the electrons are greater than the protons. Okay, and the last example is the magnesium. Magnesium is located on group 2, which means it has 2 valence. And magnesium is a metal, meaning it will lose electron in a chemical bonding. And according to our diagram, magnesium has a positive 2 charge. And since it loses some electrons, it will become cation. I hope it is clear to you. To wrap it up, again, I will just repeat the terms and all the idea that are very significant in this lesson. If the element is a metal, it will lose electron because it has a low electronegativity. If the element is a non-metal, it will gain electron because it has a great amount of electronegativity or the tendency to attract more electrons in a chemical bonding. And the one that will lose electron will become the cation. The one that will gain electron will become the anion. Remember that cation is a positive atom and the anion is a negative atom. So positive meaning protons are greater than the electrons. An ion meaning the electrons are greater than the protons. Okay? And for you to know what are the symbol and charges of the elements, just look at the diagram of the periodic table because all periodic table has a charges of the elements. And for you to know the valence number of the elements, just determine what are the group number first of the elements involved and you will know how many valence electrons are present also. So that is how you will answer this activity on your module. Okay? I hope it is clear to you. In activity number 3, you have to supply the missing data in the table for you to complete the activity. So I will give another example again. It is one of the crucial activity in module number 3. So your table in module number 3 will look like this: reaction, chemical reaction. So the first one, I will give an example, sodium and chlorine. Like what we did, you have observed that sodium transferred its electron to chlorine. So there are two atoms involved here. One is sodium and the other one is chlorine, right? It is very clear in our diagram that the atoms are sodium and chlorine. So how many valence are there in sodium? Sodium belongs to group 1. So it has 1 valence. Chlorine belongs to group 7. So it has 7 valence. So if you want to check if it is correct, just look at your periodic table. So look at the diagram so that you will know how to answer the third column here. How does the transfer happens? Clearly in our diagram, sodium transferred the electron to chlorine. How many? Only one, because you can see here one dot only. That represent electron. Take note of that. So one electron is being transferred to chlorine and one electron is being received from sodium. So to chlorine from sodium. Okay, from sodium to chlorine, which is only one, depending on the dots. So what is the ion form? So the sodium, since it is metal, since it loses, it becomes cation or positive. Okay, and the chlorine, which is a nonmetal, receive one electron, so it becomes an ion or negative. So this is the ion. How you will write the ion for the sodium and chlorine. So this is your name, compound and chemical formula. NaCl will become like this. Just copy. Okay. Second example. K is potassium, a metal, and chlorine, as we all know, is a non-metal. Okay. So what are the two atoms here? Obviously, we have potassium as K and Cl for chlorine. How many valence are there in potassium? It belongs to group 1. So meaning it has only one valence. Chlorine, we know it is 7. So how does the transfer of electron happens in potassium and chlorine? So since potassium is a metal and chlorine is a nonmetal, the transfer will be from potassium to chlorine because potassium has a low electronegativity compared to chlorine. So one electron only will be transferred. As you can see, there is only one dot. One dot meaning one electron. That explains why it has one valence only. So, one electron to chlorine and one electron from potassium. So, from potassium to chlorine. So, basically, the valence electron is the one responsible for the chemical bonding. So, the one valence is the represent the one dot. Okay, the 7 valence represent the 7 dots. So how does the ions will look like in the potassium and chlorine? Since potassium is a metal that will lose electron, it will become cation or a positive charge. And chlorine as a non-metal will gain electron, so the electrons will become too many compared to protons, so it will become negative charge or an ion. Last example. So it will become KCl, potassium chloride. Last example is calcium and sulfur. So the two atoms here are calcium and sulfur. So how many valence are there in calcium? It belongs to group 2, so it has 2 valence, while sulfur belongs to group 6, so it has 6 valence. So just check your periodic table to confirm. So how does the transfer happens? Look at the diagram. From sodium to sulfur. Why? Because calcium is a metal. Sulfur is a non-metal. So two electrons will be transferred to sulfur and 2 electrons will go from calcium to sulfur. Okay? Why 2? Because according to the diagram, it has 2 dots. Why 2 dots? Because it has 2 valence. The valence will determine the dots number of the element. So, which will be the cation and anion? Definitely, the calcium will become the cation here or the positive because it loses 2 electrons. And the sulfur now will become the anion or the negative because it received 2 electrons from the calcium. So definitely the non-metal will be the one to gain electrons and the metal will be the one to lose because of their electronegativity values. So the chemical formula will look like this. Okay, so basically all you have to do is to follow the format that I gave you now. So atoms, this pertains to the element involved in the reaction. The valence, you already know how to do that. That is to locate first what group number is that. And then the valence will also determine how many dots are present in the element. And in the transfer, just look at the diagram. So looking at the diagram, it always starts from metal to non-metal. Why? Because of the strong or high electronegativity of the non-metal, meaning they tend to attract electrons. They tend to get the electrons of the other element which has a low electronegativity. And the one that will lose will become the positive. The one that will gain electron will become the negative. So that's the rule and that's how simple is that. So for you not to be confused, all you have to do is to follow the rules and I hope you write down all the important information I gave you in this lesson. Okay? If you have some question, don't hesitate to ask me. In activity number 4, another difficult task in the module number 3, on page 8 or page 9 of your module 3, there are ion puzzle there. So color the ion puzzle pieces there according to the legend provided on page number 6. After coloring, cut it out and then combine the puzzle piece to make a compound. So you just follow the stability. How many electrons should be or should the compound have to attain stability? They should have 8. So, for example, we have magnesium, which has a positive 2 charge. I will combine it to 6 charges to make it 8. So, oxygen has a negative 2. And then, write the chemical formula for the final compound. So, write the chemical formula for the final compound. You can do this on your notebook. So, for the magnesium and oxygen, since they have both 2 charges, so just copy the symbol. Okay? So the chemical formula will be MgO, Mg for magnesium and O for oxygen. No need to write the charges since they both have 2 and the chemical name will be magnesium oxide. Just change the last syllable to IDE. So and then followed by the check your understanding, post-test, and reflection. So read and answer all exercises. So I hope this lesson helped you to understand chemical bonding, specifically ionic bonding. Next time, we will gonna talk about the other bonding, which is the covalent. But for now, complete your module number 3, and I hope you've gained something today and you can apply it in answering your module number 3. Before we end up, this is the reminder assignment for you or things to accomplish this week, module number 2 and module number 3. I will not give you performance tasks because there are 2 modules for you to accomplish this week. It's all about module 2 and module 3 and then quiz number 3. Okay? So these are the things you have to finish for this week. And if ever you have some questions, feel free to ask me through Messenger or any way or any mode of communication. Okay? So I hope you can submit it on time. That's all for today.